the next presentation by Frank Cooper. Frank cannot be here. His nickname is Big Frank, so if he would be standing next to me now, you would perfectly understand this nickname. So Frank has recently, unfortunately, retired from his role as a senior lecturer at the Birmingham City University School of Jewelry, where he was also responsible for the Center for Digital Design and Manufacturing. Despite his retirement, Frank has continued his work with companies in the UK jewelry industry as an independent consultant. Frank is an award-winning and well-known speaker here at the JTF, as well as the globally renowned Santa Fe Symposium on Jewelry Manufacturing Technology, where he was willingly sharing his knowledge and insights into the development and use of various 3D printing technologies and additive manufacturing, particularly the additive manufacturing of precious metals. So in his overview paper on additive manufacturing and applications, he will cover the development and use of 3D printing in the jewelry industry. He will also discuss in some detail the current state of the art and finally take an in-depth look at the future. A future where we can expect to see innovative new technologies on the horizon that could transform some aspects of jewelry design and manufacture from the more traditional use of 3D printing into the world of additive manufacturing in the global jewelry industry. So Frank, please start.
Thank you, Jörg. My apologies for the technological cock-up earlier, but let's hope this works this time. So we're going to have a look at the DNA of 3D printing, which eventually led us to the world of additive manufacturing. Printing led us to 3D printing via technology, which eventually led us to additive manufacturing. We're going to have a quick look at the past, a quick look at the present, and a slightly longer look at the future. In the beginning, there was block printing, wood block printing, developed in Japan about 2,000 years ago. As things move on, as technology moved on, we had things like the Gutenberg press, the mechanical typewriter, lithographic printing, and mechanical lithographic printing, and of course, the Xerox photocopier. Technology continued to move on, particularly with computing power, which gave us word processors, desktop computers, laptop computers, tablets, and of course our very favourite smartphones. 3D printing was thought to have developed from topographical modelling and something called photo sculpture, both well worth researching if you have the time and the inclination. Modern 3D printing was developed by this guy, and first Charles Hull, and first patented in 1987. His process was known as selective laser sintering, SLS. This led us to selective laser melting, or SLM. And this, of course, eventually led to additive manufacturing. Additive manufacturing, or metal printing, has a number of different names. Direct metal laser melting, direct metal laser sintering, selective laser melting, electron beam melting. Well, there's a general catch-all term used, which is powder bed fusion. I was at this point going to cover binder jetting, but clearly Alejandra and Andrea have made a far, far better job of it than I ever could have. So let's check out the road to additive manufacturing by the jewelry industry. And this is a personal journey down my road to additive manufacturing via the School of Jewelry in Birmingham. it all started a long time ago with the Sanders Model Maker 2, a very temperamental Sanders Model Maker 2. We eventually invested in a number of different solid-scape machines, which is the current version of the Sanders Model Maker 2. And these machines do produce excellent quality, repeatable and castable items. We also had EnvisionTech per factory. Again, inclined to be a bit temperamental, but over the years, EnvisionTech have developed a faster process. And again, they produce usable materials, very good for casting, and across a range of different resins. The Formlab systems are gaining a lot of traction in the UK, both for cost and ease of use. It also comes with a very nice and effective wash station and a reasonably sized build area, and it builds from the bottom up. Now, hopefully this video will give us an example of how this technology has moved on. This information was only released early in 2023.
First, we brought you a 3D printer that enabled you to make anything. Now, we're pushing the boundaries of what you can do with our 3D printers by bringing you the tools you need to make at scale. Formlab's automation ecosystem, hardware, software, and material streamlining tools that transform your 3D printers into autonomous fleets for 24/7 printing made easy. Together, Form Auto, Fleet Control, and our high-volume resin system maximize throughput while minimizing labor and costs, so you can scale with demand more seamlessly than ever before. Instantly automate production with Form Auto, an extension of your 3D printer that enables non-stop throughput without interaction, reducing cost per part with labor savings of up to 80%. Enabled by our patented quick-release technology, Form Auto seamlessly removes parts from Build Platform 2 and starts the next print, so production doesn't have to stop when you leave work. Scale and align your business with Fleet Control. Advanced new features within Formlab's dashboard management software that equip your team with the agility to use shared printer groups from anywhere. Leverage a centralized queue that automatically sends your prints to the right printers at the right time, boosting productivity across your entire organization. Cut down on labor and waste with our high-volume resin system. At 5 times the capacity of a standard cartridge, you can print with 80% fewer interactions, 96% less packaging, and a lot more productivity. Whether you're using to scale production. First, we brought you.
Well, I hope you'll agree that showed in some detail how these technologies move on very quickly. Another piece of equipment we had great fun with at the School of Jewellery was the 3D Systems project, which eventually morphed into the 2500W version, which we absolutely loved to use, principally because it had, again, excellent materials with great castability, but also a rather large build plate, which made it appealing to the larger jewellery manufacturer. We also had a DWS X-Fab, a green laser machine, a great workhorse in the school, which again produced items in a resin that was castable and easily used. So we've gained all this experience in 3D printing, and over the years then the idea of additive manufacturing began to gain traction in the non-jewellery industry, and we decided to investigate and perhaps invest in the technology. So the additive manufacturing of precious metals. Let's start off with what is additive manufacturing. Additive manufacturing is the process of creating an object by building it one layer at a time. It is the opposite of subtractive manufacturing, in which an object is created by cutting away at a solid block of material until the final product is complete. Technically, additive manufacturing can refer to any process where a product is created by building something up, such as molding, but it is typically used to refer to 3D printing items. I'm going to report now on some research carried out by an ex-student of the school, Maria Paparosi-Shipman, who now works for the Diamond Centre Wales on a Welsh government-funded project to explore the different technologies and options for the additive manufacturing of precious metals. So the research criteria she's used: number one, ease of use; number two, material security; number three, the surface quality; and number four, the economic viability, largely based around the build plate size and how much material is required to fill the chamber. So the technologies that were analysed were EOS, exact metal, desktop metal, hollow, and alpha laser. So this is me back in 2016 taking delivery of our Cooks and Gold EOS MO80. It should be said here as well that Maria also worked for Cooks and Gold at that time, and she was the senior technician in their additive manufacturing section. So she has a great understanding of this technology and its potential. These are some early experiments into using the machine where we were trying to push it to the limit. But the key thing here to remember is that additive manufacturing is not a replacement for casting. It is an alternative method of producing precious gold items, of producing jewellery. Here we can see some early experimental work by the students at the school. An early lesson learnt by both ourselves and the students was the use of support structures. Using an SLM process, support structures are integral into what is produced, but they can be removed and post-processed to produce good, usable products, as you can see here with this watch bezel. What sort of products could you turn this technology towards? Well, clearly intricate and detailed items that are difficult, if not impossible, to cast and finish. This was one of our favourite experimental areas. Hollow items. We described them as jewellery items that had volume with very little mass. And of course, one of the key things you can do with it is flexibility and articulation. You can build chain mail, moving parts straight off the machine with no secondary sub-assembly. Here you can see an example of a flexible bracelet in two materials, biomaterials, so white gold on one side, yellow gold on the other side, and produced by Cooks and Gold on one of their EOS machines. A great example of how you can build articulated items directly off the machine. This is a close-up of the surface of that bracelet before polishing, and it gives you a good indication of the clever design. The clever design process that was used to give it that flexibility and articulation. Here's another example of a chainmail type build, specifically for an Austrian company called Boltenstern. Once taken off the machine and processed, you can see we have a fully movable and articulated bracelet and necklace. Another thing you can do with this technology is to stop the build halfway through and insert pearls, crystals, precious gems into the build, and then restart the build and build into it articulation. So here we have a short video of showing the inserted items being taken off the machine. This is interesting. This has just come to my notice again in early 2023. Bentley Motors have a very exclusive range of cars that they're selling, into which they've introduced solid gold parts. So you can see here that the start-stop button, and clearly marked there on the left-hand side is the UK hallmark. Now you might think and look at this and say, well, actually you could cast that quite easily, which is absolutely true. Although it's not stated in the press releases that I've seen so far, it's my estimation that this is probably hollow. Again, another example of volume without mass. So let's have a look at some of the machines that Maria investigated. There was the exact metal group of machines, and clearly the XM200C, which is about the size of a filing cabinet, met all the criteria. It's neat, tidy, quite easy to access and use, and the build plate is about the right size and scale for the small to medium jewellery manufacturer. The desktop metal system was closely checked, but this is a true sintering process which requires debinding and post-processing in a furnace. An added difficulty with this technology is the fact that the material is held in a stick, in a crayon, in a binder. So getting that filled with precious metals would have caused quite some problems. And one that was very encouraging is a company in America called Hollow Pure Form. But they're not a machine supplier. They are a supplier of they're a supplier of a build service, a print service. And here you can see there, because it is a sintering service, they're huge desintering equipment. They offer great accuracy and very fine tolerances with a really good surface finish. They do it by a form of lithographic printing, but the key to this is their proprietary metal polymer slurry, which then produces a green state item. Once it's in the brown state, it is a fully dense part. On the right here, you can see the Diamond Centre Wales file that was used to test a build on the setting. And on the left here is the actual setting on the build. It's not red gold, which was the eventual aim, but it is in fact copper. Now the system that was finally arrived at and agreed on is this alpha laser system. Particularly because of this system for holding and containing the materials. Also, their debinding, not debinding, depowdering system is very clean and neat. And also their software allows the Diamond Centre Wales team to actually set their own build parameters. Additionally, Alpha Laser already had parameters for platinum and silver, which they were happy to share as part of the process. Here we have another video that will show you the machine in all its glory. I hope you could see there the very clever cartridge system and why it does appeal. Early trials and tests on the technology, which has now been installed at Diamond Centre Wales, have proven very, very successful. They tell me that the results are comparable to castings and they're having no problem with surface finish. If you want to research this technology further, one thing I would highly recommend is you approach Damiano Zito and his team at ProGold and ProGold 3D. They are absolutely the best of the best in this technology, not only in making the technology work well, but also in what materials you can use. I highly recommend, if you have the opportunity to go over to T-Gold and meet with Damiano and his team, that you do, if this sort of technology interests you. Also, the guys at Sysma do some quite interesting stuff. Unfortunately, because of COVID and my retirement, I haven't had a chance to bring myself up to date with the latest developments at Sysma. And DWS, we'll go back to DWS because I was very impressed by their X-cluster chain building process. It just remains for me to say thank you.
Many thanks, Frank. Long applause here in the room. Speech has been very well received. Thank you again for this nice journey back to the roots of additive manufacturing up to the state of the art where we are now.